Lovely. Thank you very much. So, welcome everybody. Good afternoon, good morning, good evening, depending on where you are. Welcome to the 17th PMIP week's session, the Value Climate Modeling Intercomparison Project web-based interactive global seminars. PMIP wings is far easier. In case you don't know me, I'm Charlie. I am from the University of Bristol and UCL, and it's my pleasure to share for you today. So today is all about some reports from recent workshops, namely the past 2K and Interglacials workshops. So we're going to hear about some of the report back from those. Note that we are not going to be talking about all of the planned PMIP, TMIP 7 simulations. There are others that we won't talk about today, such as the mid or late Pliocene, the Miocene, the early Eocene, the LGM, but they will undoubtedly be talked about in the future seminars. So we have actually four speakers today that will be talking in pairs. Firstly, we have Qiong Zhang from Stockholm University and Myriam Khodri from the Institut Pierre-Simon Laplace in France, and they will be talking about the past 2K new community exercise. Then we will have Christian Stepanek from the Alfred Institute in Germany and Louise Sime from the British Antarctic Survey here in the UK. They'll be talking about the Quaternary Interglacials kickoff workshop. We're going to follow the usual structure, so about 20 minutes for the speakers, followed by questions. Either raise your hand and I will see you, or if you prefer, use the chat and I'll read them out. And finally, before we start, a very quick announcement about our next seminar, Wings 18. This is in a couple of weeks and will be a discussion of paleo and how it fits into the AR7. So we're going to have two speakers, Fabrice Lambert from the University of Chile and Pascal Bacalou from the LSC. So that is on Thursday, the 20th of March at 11 a.m. Chile time, which is 2 p.m. GMT, 3 p.m. CAT, and so on. So please put that in your diaries. Anyway, back to today. I will hand you over to Qiong and Myriam. So, Myriam, do you share your slides? Yeah, we can see those perfectly. So, whenever you are ready.
Thank you, Charles, for this introduction. And thank you, Massa, Chris, and all for inviting us to share latest information and progress on this new working group focusing on the common era that we basically call PASS 2K working group. And we wanted to make a short report on the kickoff meeting starting this community exercise that was organized in Paris at IPSL end of November last year that gathered key experts working on the subject to try to outline current status and the way forward. So I want to acknowledge all the participants to this workshop that helped us put this slides together. And I wanted also to show this recent paper that was published end of last year that discuss how the past 2K or common era was discussed in several IPCC report. And I think it's pretty timely to maybe make some sort of current to draw some conclusion on past reports before going further. But we won't discuss all of this in detail today. As we say, as the chart said, we're going to report on what we have been doing and where we want to go. So Paris meeting was organized over 2 days. We had the 12 key experts and 3 sessions organized around different questions, reviewing progresses and current challenges in addressing and reconstructing natural forcing that are relevant for the common era. Also discussing protocol, what could be improved, and also ensuring alignment with PMIP 7 activity, in particular the historical period, which is quite relevant for the common era. So in a few words, the current activity, I will give more details later, but we are currently updating PMIP 4 forcing datasets with the latest high-resolution data. So we discussed what is already available, identified gaps, and a way to improve and address these gaps. And we have set up several subgroups and a method to work over the next 2 years, aiming to have the best up-to-date forcing data sets, modeling protocol, and also engaging the broader community within PMIP, but also outside PMIP and outside CMIP, in particular community involved in PAGES, because there is a large community of scientists interested in the common era beyond PMIP and PAGES, and I think it will be interesting to involve them while building this working group and a protocol and addressing and outlining key challenges scientifically, but also in climate modeling. And finally, we also plan to document all this work and the new protocol and forcing in the GMT paper, updating the reference paper by Young Klaus et al. That was used for CMIP 6. And we hope that we will have something to share with you early next year. So now the scientific question that we outlined key aspects and that this working group could push forward concerns improving our understanding of the mechanism underlying natural climate variability. So before the influence of anthropogenic forcing on climate change, through coordinated model experiments and improved reconstruction from PAGES. So we want really to bridge both activity so that we can hope to constrain and understand the natural baseline of variability over the 2K, but also over the last 100 years to provide the context for interpreting recent climate changes and also improve our understanding or better project the impact of future global warming on natural variability and on regional climates. So this requires improved external forcing, addressing key issues, identified issue in latest data sets, design an experiment protocol that allow addressing this scientific question while involving more scientific community beyond PMIP. Of course, this will hopefully help to inform not only our understanding of past climate changes, but also this will have implication for future climate projections. So here, this is a rough outline of the protocol. So we aim to cover as a tier 1 experiment, first, like most top important experiments, the whole 2K. PMI4 was focusing on the past meal, last 1,000 years. There were like a tentative to push it, not by Young Klaus, to push it, Johan, sorry, over the 2K. And I think it would be nice if, as part of PMIP 5, we cover the 2K because there is a large interest for many community and scientific questions to be addressed as well for the first millennium. We want also to provide guidance to spin up such transient experiments, starting from a pre-industrial control with the mean background condition typical of the beginning of the Common Era, and also providing new forcing constraining long-standing issues that are useful for both groups using GCMs and groups planning to use Earth system models with interactive vegetation, for example, or other tracers. We also discuss tiered experiments for adding additional member, which will be interesting if we want to address questions such as signal to noise ratio regarding the influence of external forcing from natural sources and separate the noise of internal variability, which is important when doing model data comparison. We could also think about designing some key experiments studying the effect of solar or volcanic forcing in isolation and their impact, for example, on the ocean dynamics or even on the vegetation. We discussed as well doing eventually sensitivity experiments testing alternative forcing data sets. So this is under construction and discussion, and we will refine this involving the community over the next months. So quickly, I wanted to give a quick outlook of what we mean by updating forcings. So the main forcing that were important over the Common Era are volcanic forcing, solar irradiance, land use, and greenhouse gases. And the volcanic forcing is one of the most important one, and several limitations were identified, relying on PMIP for experiments. And we decided for this next exercise to leverage all the proxies that are available, the latest advance in analyzing ice cores, not only analyzing sulfur deposits, but also the isotopes from sulfur, which allows separate what is a stratospheric from the tropospheric component, and also identify tropical, better discriminate what are tropical sources from extratropical sources, which is not always clear so far. Involving as well beryllium-10, which was not used so much in previous reconstruction, while it helps discriminate the latitude of eruptions, and also the seasonal timing of eruption. So some work will be done as well to disentangle like cluster of eruption using TEFRA and MicroTEFRA and multi-proxy tools to identify some difficult, like unknown events. We will also include small eruptions, which were ignored in previous forcing data set, like VEI4 eruptions, so basically smaller than 10 teragram, because we think that it might be important for background, for the background forcing background condition in the stratosphere, and also improving the representation of extratropical eruption and big eruption, which were not well represented in previous forcing. And we will, of course, ensure consistency with the CMIP 7 forcing over the historical period. So this new forcing data set will explore also uncertainty estimates. So we will provide an ensemble of forcings. This will be the version 5. That will build up on the version 4 that was published at the end of last year by Michael Siegel and Matoué, and this new version will involve more colleagues. And I wanted to show this version that was published at the end of the last year, showing that a lot of work has been done already, taking into account some microtephra, trying to help identify the source of emission and identify key eruption, but also adding more volcanic extratropical volcanic eruptions, both in the northern and the southern hemisphere, and also improving the representation or inclusion of small eruptions that might that are below 10 teragram that are important, but also big ones. We want also to leverage historical sources. I wanted to present this recent work, which is quite nice, because historical sources can help as well reduce uncertainties in the season of eruption. From ice cores, we can deduce the year of the eruption, but not the season. Sometimes there's unknown, and this recent publication leveraged historical sources documenting the observation of aerosol in the stratosphere that can help also combined with ice cores help improve the chronology of the volcanic forcing. Regarding the solar forcing, we really also want to improve the current data sets and update both total solar radiance and spectral solar radiance using the Satire model version. That was the case also for PMIP4. And we want to use Satire because this is what is used now for PMIP7 for the historical data set since 1850. So to ensure consistency, we will use the same model. However, we will update the forcing using the latest data about using the latest sunspot numbers, including uncertainties, which was not done so far. When I mean uncertainties, means that we will use a consensual estimation, but also consider a spread around these central estimates to take into account uncertainty around the SNN numbers. We will also rely on new annual radiocarbon and beryllium-10 data that are available now, that will be published by the end of the years, that allow improved reconstruction of the long-term trend, but also on the 11-year solar cycle, which is a major advance. And discussion were also considering the uncertainty related to the solar and geomagnetic effect on the reconstruction. And Raymond Muscheler proposed to use the latest Bayesian method they've been developing to leverage high resolution data that will be available by the end of the year to separate and correct from the geomagnetic field and ECP events. So we will have much better forcing data set to work on for the next exercise. So this new clean cosmogenic data set delivery, as I said, will be available by the end by June this year. We will rely on Satire, but also test other models because we want to make sure we are not missing some important development in the solar modeling community. And of course, all of this will be done by bridging with the PMIP17 working on the forcing data set after 1850. So our goal is to have something ready by the end of this year. And to complete the collection of updating for things, we also want to reconcile land use and atmospheric greenhouse gases reconstruction for ice cores. And for that, we have a key expert that will be handling this issue, updating greenhouse gas forcing over the common era using the latest ice core estimates, and also provide land cover changes protocol using the latest HIDE model version, ensuring consistency and filling the gaps, the current gaps between greenhouse gas reconstruction and land use cover change. So I won't get too much into details, but this will be really a great progress compared to what is currently available as part of PMIP4 and also what is already on the table for PMIP7 because the data set is already available over the common era and we want to revise it. So we will also, for groups using Earth system model, provide a protocol allowing to run with and without interactive greenhouse gases, providing a history of gas fluxes from ice core, which will be interesting for comparison. And for groups that have peatland in their models, also a protocol. And for modeling groups with isotope-enabled carbon, we will also provide radiocarbon prediction. And the timeline is also end of this year. So to wrap this up, this is the time lapse for PMIP7 for the fast track that is ongoing. That should be delivered, I'm correct, January 2027. We had a first workshop end of November. We're going to present current activity at the next pages or open science meeting in May in Shanghai. We have a talk And we aim to inform the Pages community about this activity and also collect feedbacks on what could be interesting for this community and engaging them in building the next protocol for this PAS2K working group. Another meeting is planned this time in Stockholm that will be hosted by Qiong in September this year to update and to wrap up what has been done. Hopefully we will be able to document all this work in a GMT paper that we hope to submit early next year along forcing dataset for testing. So this is a tentative schedule, and ideally we could imagine that we could start running the experiment in 1 year if all goes well, and so that we are not too late or behind schedule for the for the IPCC next IPCC report, so that our work can be useful for the next assessment. And that's it for me.
All right, thank you very much, Myriam. Thank you very much. So we have time for a couple of questions. Anybody want to ask a question for either Myriam or Qiong?
Hi there. Can you hear me?
Yeah, absolutely fine.
Hi. Hi there. That was really interesting. Thank you. Just one quite sort of basic question was when you talk about these volcanic forcings, are you providing the aerosol concentrations to the models, or are you providing the radiation impact?
So I think both, since we want to align with the historical forcing data set that was provided recently to modeling groups, we will use the same format. So we will provide radiative forcing data set, but also emissions. If that's what you're asking.
Yeah, great. Thank you.
Anybody else? Any other questions?
I have a question. I'm sitting next to Myriam. It's
Yep.
Sorry. I was wondering about the land use data and the consistency with the historical.
Yes,
Is it warranted or not? Or...
Yes, I mean, warranted, I don't know, because the historical forcing data set for land use, there is one available right now. And we are looking into it, and these forcing data sets covers the common area. However, it has been built by community working over the historical period after 1850. So we want to have a look at it and update it based on the latest data and the latest height model. This will be done by Kiss, I don't know how to spell his name, sorry, who was at the meeting. Kees Klein from Utrecht, who is the person developing high model. So he wants to use the latest high model version and the latest sources and also population. And I think he wants to do something much more advanced compared to what is available. To my understanding, the dataset, land use dataset, has been updated after 1850 for CENIP 7. But before, I think it's the same as CENIP 6. We're not sure, but that's our feeling. So we are investigating this right now.
Thank you.
Okay, lovely. Any other questions before we move on to our next speaker? If you do think of any in the meantime, please put them in the chat, and maybe Myriam could look at the chat every so often in case there are other questions for you. All right, so in that case, I suggest we move on to Christian and Louise. Would one of you like to share your screen? Yep, we can see that, so over to you.
Hello, can you hear me?
Yeah, absolutely fine.
Wonderful. So thanks a lot for attending this PMIP Wings meeting today. Louise and myself would like to give a short report on the PMIP Quaternary Interglacials kickoff workshop that we had beginning of this year here at RV in Bremerhaven. And basically, this was assembling a large group of people interested in interglacials, who have worked before with interglacials in PMIP, who plan to work with interglacials to get an idea what are the interests and what could be done. So the aims of the workshop were reflecting on PMIP4 efforts and achievements. We wanted to update each other on the current research that everyone is doing in modeling and reconstructions to see where are new avenues, maybe for model experiments and for comparing with proxy data. We wanted to get a feeling for the scientific interests and the research questions that we would like to work on with quaternary interglacial simulations in the next round of PMIP. And one part was also to establish interest groups that then prepare the next modeling intercomparison, looking at available proxy data, compiling benchmark data, and thinking about the modeling protocols. And most of all, I think this was the most important part in comparison to other things as well, is to get to know each other, to connect with each other so that we have a good basis for the future work in the next coming of years. Before getting into some of the outcomes of the workshop, a few numbers. So we had in total 7 talk sessions and 3 discussion sessions. We had in total 36 speakers that were on site or spoke from remote via WebEx. We had in total 25 participants on site and in total up to 70 participants via WebEx. I would like to thank everyone who spoke and who contributed to discussions at the workshop. I personally found it very inspiring and very interesting. So thanks a lot to everyone who was involved, and already thanks a lot to everyone who will be involved in the next steps. So I don't think it makes a lot of sense to go through details of the program, but you can find this online in the website of our work group, PMIP Interglacials DE. There's a link, there's a short description of the workshop, and here at this orange marked link, you can find details of the program. I already spoke about the fact that we also wanted to meet each other and learn to know each other. So at the first evening, we had a social event, icebreaker, conference dinner, however you want to call it, where we met then in the climate house here in Bremerhaven, which is an exhibition about a climate system where you travel around the Earth on the 8th degree longitude circle and can learn a bit about the world, about the climate zones and so on. And I thought this was a quite fitting place to meet each other in the evening and to have some deeper discussions on what we heard today before already and what we were hearing, what we wanted to discuss further during the meeting. There were a lot of details that were discussed, and I cannot go into everything, but I would like to highlight 3 initiatives that, from my point of view, come out of this meeting. First of all, we have the traditional PMIP simulations, and for those is an aim for inclusion of early interglacials, so not to look only at the mid-Holocene and the last interglacial 127,000 years ago, but also going to earlier time periods to somehow increase the sample size of quaternary interglacials in PMIP. Then there are 2 rather new initiatives, namely looking into higher resolution models. So there's the well-known HIRIS-MIP initiative, and one could combine HIRIS-MIP protocols with PMIP simulation protocols for 6K and 127K before present, and then have a look what high-resolution models would tell us in comparison to those resolutions that we normally look at. And then there's potentially also a new initiative where we would like to look into coupled ice sheet climate models and see what they would tell us about quaternary interglacials. I will go quickly through these 3 different pillars of the potential future PMIP quaternary interglacials efforts and give you a bit more information on that. So the first question is, why would we like to extend to early interglacials than 6K and 127K? And why would we like to do it now? I think the major idea is that these interglacials, Holocene and last interglacial, have proven very useful for doing climate research. But there are a lot of questions going on that would enable or would need to be enabled by looking also at other interglacials. And maybe now is the time to do that, to look, for example, at MIS 11Z or at MIS 31, because particularly for MIS 31, there is now the idea that maybe next year we will have very detailed CO2 data going back to that time, so that we can make a meaningful model protocol from the carbon dioxide and other greenhouse gas side for the simulations. And in addition, also there are other modeling intercomparison project efforts already on the way that are dealing with MIS 11 and MIS 11Z in particular. So there would be now a time to, let's say, harvest or use some synergies that are in the community to then make, with a little bit of effort, additional PMIP simulations that extend our working range from the last interglacial towards earlier parts. What could we expect from such an exercise? So, of course, MIS 31 and MIS 11 were much warmer. They had different orbital configuration, different orbital forcing. MIS 31 was a super interglacial, maybe the warmest one, or one of the warmest ones at least, for the last couple of million years to 1.5 million years. We expect also that MIS 31 might have much higher CO2, and all these additional differences in the forcings in comparison to the last interglacial hopefully opens up some doors for exciting science, including vegetation, cryosphere feedbacks, and so on. One idea how such a modeling protocol for the classical PMIP quaternary interglacial simulations could look like would be, again, a multi-tiered protocol. Details are still in discussion, so this is just a glimpse how it could look like. So, for example, we could look in tier 1 again at the mid-Holocene and the last interglacial, and then have a look into higher tier simulations with earlier interglacials, and then also make sensitivity studies regarding ice sheets, discharge, dynamic vegetation in the models, and sea level as well. If we look then into the motivation, then it's clear, I think, why we would like to keep 6K and 127K also for the future. First of all, they have been proven very useful, although, of course, they cannot do everything right. They would act as a link to earlier simulation from PMIP4, so that we can somehow track the progression of model evolution and its impact on the skill or on the simulated climates. Then we also have, as many of you know, abrupt 127K, which is a type of 127K simulation that is part of the full CMIP7 fast track. So we hope to put this part of paleoclimate research also on a wider stage. Then the motivation for earlier periods, already noticed it a bit, is that we have then long interglacials that make spin up and that are based on a spun up PI control a bit easier and less problematic, in particular for the Antarctic ice sheet regions. The fact that we have different expressions of the glacial ice sheets there, of the ice sheets in the northern and southern hemisphere, could open up some contrasting science, and isolation forcing will ensure that we have potentially interesting science being enabled by those simulations. And in particular, of course, now we have the potential to prescribe proper, well-known carbon dioxide concentrations. Then if you look for motivation for high-resolution PMIP simulations, in general, in climate science, there has been the approach in going to higher and higher resolutions in order to reduce the need for parameterizations in the models and to enable more spatial detail also in the model output. And of course, with PMIP, we are in a bit of a problem here because it's difficult to run those simulations for thousands of years in order to spin up the ocean model. So one has to come up with a smart, let's say, setup and limit the focus of the simulations and of the scientific analysis only on those parts that can meaningfully fully equilibrate it in, let's say, a couple of 50 of decades to 100 years. There are links to the Iris MIP protocol that work basically from initializing, for example, from 1950, and then run the simulations for 50 to 100 years. We could do a similar effort for 6K and 127K forcing then. The beauty of these setups is that we do not have to modify the land surface configuration, which of course would make such a short-term simulation very complicated. And this model protocol would also be in relation to our abrupt 127K simulation, where we also ask modeling centers to just produce a relatively short simulation of 100 years or so from a spanner PI controlled state. So this high-res PMIP effort could sit very well in existing efforts. The setup of the simulations would be very similar to the tier 1 simulations with Holocene and last interglacial 127K. The scientific focus would be, of course, to look at those quantities and those characteristics of climate that you cannot very well look at with lower resolution models. So topics are high resolution proxy records to compare to high resolution model output from simulations, or to look at hydrology and at heat extremes that, of course, are better simulated if you have a higher resolution. There will be then probably a separate modeling protocol paper that links PMIP with high-res MIP methods. So for this specific effort, we would have a separate modeling protocol probably. Then motivation for maybe using interactive ice sheets in the quaternary interglacials and PMIP. So it was very well discussed, and I think everyone agreed that running the classical PMIP style simulations with fixed ice sheets is, of course, useful because you can easily run your models, you can involve a lot of modeling groups, and you can get probably a relatively large ensemble of model outputs, but you can also not do everything with that. In particular, if you have transient simulations over, let's say, deglaciation or so on, it's of course nicer if the ice sheets can interactively evolve with the climate that is simulated in the model rather than maybe stepwise prescribing changes over time. There are a lot of efforts and projects in the community that now run fully coupled ice sheet climate models. So technological advances allow now to maybe do this also in a larger group within a MIP. As I already said, this would probably lead to improvements for interglacial transient simulations and would allow us to explore some changes and some tipping points in climate system that we cannot address with the constant fixed ice sheet simulations. But to have this happen, indeed, engagement is decisive. So at the moment, there's maybe 1 or 2 groups who would be interested in contributing to that, but that probably will not yet make a MIP. So if there's interest in the community for this, this would be a place where you can engage yourself in and make it happen. The next steps that we are thinking of now. We already had some first meetings to explore ice sheet and meltwater boundary conditions that could be used for the early interglacials. All this has been so far rather unofficial, but we are still establishing some work groups where people then can contribute to all these efforts. And once we are finished with setting up our boundary conditions, we would provide some preliminary boundary condition data on our website and also ask for feedback on this from the different modelers. Our aim is to have a PMIP 7 quaternary interglacials protocol paper for the traditional PMIP style simulations ready by the end of 2025. Work on high-res MIP protocol papers is already going on as well. I do not know yet whether we have a fixed timeline for this, but the potential is there that these things could run pretty much in parallel so that by end of the year, we would have a preliminary protocol on which people then could comment and start to set up their simulations. We also have a new mailing list for PMIP Quaternary Interglacial Information Exchange. This is very similar to the PMIP Announce mailing list. The technology, the background, the server infrastructure is all the same. If you would like to subscribe to this and be involved in the discussions that will happen within PMIP Interglacials, then just write, for example, me an email or directly to Jean-Yves, who thankfully has set up this for us. From the general idea of the protocol papers and the science publications, I already spoke about abrupt LIG 127K. We are working on this manuscript, and this will be submitted to the CMIP 7 special issue for the CMIP 7 fast track. I already spoke about the fact that we will have 1 to 2, depending on engagement from interactive ice sheet modelers, maybe 3 protocol papers to the CPT GMD PMIP special issue that will be set up. Not sure whether it's already set up, but will be set up. And as I said, modeling protocols should be ready hopefully by end of 2025, so that people can set up their models and run the simulations in 2026, so that we can somehow start with the scientific evaluation as soon as possible thereafter, maybe in 2027. And this is my own personal point of view on the timelines that are happening within CMIP and PMIP. I think a lot of the problems that we still have are related to the fact that we do not exactly know when our IPCC deadlines, unless they have been recently announced. But we still assume that all this has to be ready by somehow. So scientific publications and data for the ESGF will have to be ready sometime in the time frame from 2028 to 2029. So we have a bit of a tight framework for all this work that is happening now, but I think we also have a chance to finish it in time. And with this, I would like to end my part of the talk and give back to Charlie for questions.
Okay, thank you very much, Christian. Thank you very much indeed. So we got plenty of time. Any questions for Gilles?
Thanks you very much, Christian, for your talk. It was I think I didn't participate to the whole meeting, but I think it's a good idea of what we did. I was just curious. For 6K, there is no problem on ice sheet configuration. For 127, there is some problem on ice sheet configuration, even in PMIP simulation. But what about if you want to test NIS 31? Of course, you're right. We can expect we get some results concerning greenhouse gases. So this is perfectly true. I also hope, like you, that we will get that. But concerning the ice sheet configuration, what you will do?
We are currently working. Sorry, I have 2 sound sources here. I have to always mute one of them if I'm talking. Sorry. We are working at the moment with ice sheet modelers and ice sheet system scientists to establish what kind of ice sheet setups we could meaningfully use. There are discussions on minimum, maximum, extreme settings, or specific configurations. The reason why in 127K we would like to keep the ice sheet as it is in particular to keep the link to PMIP 4. So if you would change too much from PMIP 4 to PMIP 7, it will be difficult to still track the change of modeling advances and improvements of parameterizations and so on. For the other interglacials, we are discussing also changing ice sheet configurations, but this is very preliminary work yet. I do not know, Louise, whether you would like to add something to this point of view. We are still not sure yet whether we will have both, namely pre-industrial ice sheets or modern ice sheets and the modified ones. Because even if you do not modify the ice sheet, you still get some scientific relevant results from that. So for example, if you would like to link past climate to the future, and you're not so much interested in the details of, let's say, of the circulation at the time, then having a modern ice sheet is also not the worst, but clearly there are some applications where one would like to modify those.
I could comment briefly if you like, but Christian, I think you covered pretty much all of that. The only other thing, I mean, it's a very good point that we just won't know very much about the ice sheets, especially if MIS 31 goes in. And there's not many of the standalone ice sheet modelers who've actually done runs for it. So we will be a bit limited. But just as one comment from them, it could still be helpful to them as well, actually, if we had a max and min versions for both Greenland and Antarctica for MIS 31, because it might actually be quite helpful for them to then subsequently drive their standalone ice sheet models. So if we include this, it will be potentially a slightly two-way information exchange between the ice sheet modelers and between the PMIP community, which I think in itself is quite nice. I think, Christian, you covered everything else. Thank you.
Any other questions from anybody? So I have a question while others are thinking of questions, which may be a silly one. Apologies if it is. So in the last round of PMIP, the interglacial simulations, the experimental design for the models was relatively simple. All we changed was the insulation and the greenhouse gases. For those models that don't have interactive ice sheets or interactive vegetation or whatever, is there any plans to implement into the experimental design other prescribed boundary condition changes, like vegetation, for example? So rather than using a modern vegetation, you use something more appropriate for the mid-Holocene or lake or whatever.
Yeah, so in PMIP4, there was already the possibility to test the vegetation. There was one specific simulation in the protocol paper described by Otto Blies et al., where you modify the vegetation in the Sahara in your model and where you modify the vegetation in the high latitudes. So things like this have been around. Our input from the various surveys that we had, we asked modeling groups what type of models they would like to use for their contribution to PMIP. Most of them actually have now dynamic vegetation. So we probably would again open up the stage for those who can use dynamic vegetation to use that. And for those who cannot, to either use present day modern vegetation or pre-industrial vegetation, let's say like this, or to prescribe something from data sets that we would still have to establish. So for 6K, there's a bit of information around. Not sure how much information we have for 127K and how much information on vegetation for earlier interglacials we have. I actually have no idea at the moment. That's something to discuss in the data benchmark groups. But I tried to outline this. I hope I succeeded, that at least the tier 1 simulations and also those parts of the tier 2 simulations, they will not necessitate necessarily to modify any ice sheet configurations. So all modeling groups that don't have inductive ice sheets and that do not want to do a lot of changes in ice sheet configuration and geography should still be able to contribute. And there will be probably some simulations where we change some ice sheets, but the details of this have to still established.
Okay, thank you. Any other questions for, well, any of our speakers, really? Christian, Louise, or Myriam, or Qiong? Any other questions? Yes, Massa.
Yeah, so I'm speaking on on Myriam's microphone. So one of the biggest uncertainties, I think, on the future runs is also volcanic activity, because we cannot predict volcanic activity for the future. So I was wondering if we should have a kind of investigation of typical typical impact of volcanic eruptions for also the interglacial, the last interglacial, or the LGM or other periods. What do you think?
Very good point. Something we've been discussing as part of VolMIP, because VolMIP is now also like a discussion regarding its new protocol. And VolMIP, for those who don't know, it's a model intercomparison investigating the response, climate response to volcanic forcing. And as part of CMIP 6, it focused on Pinatubo, modern eruption in 1991, and Tambora in 1815. And for the next round, we are wondering if we shouldn't bridge more with PMIP. I'm part of the steering committee of VolMIP, so of course, I think it will be nice. And we were thinking of big eruption during the LGM, for example, like Toba, or big eruption during the, I don't know, early Holocene. So if there is room for this, that's beyond this working group. Yes. But that would be nice. Yes, I think there is interest.
Maybe we could check who's interested.
Yeah.
Do you have any idea of how many groups are going to perform the
not yet. The Pastuque? No, not yet. Yeah.
So may I ask, you basically propose to have a 127K simulation just as standard, but with a modified volcanic aerosol forcing?
I mean, we have to check when there are some of these big eruptions. The biggest eruptions in the Quaternary is Toba at 74K. So it's well after the Quaternary interglacial. I think I remember there's one also around the last glacial. So, but the idea is maybe more idealized, what is the impact of volcanic eruptions changing as a function of climate background?
So it could be interglacials, the one of you choosing. Could be the last interglacial, or could be the mid-Holocene, or...
I mean, this was an idea in the air. I didn't really...
But it's very relevant because we've been discussing that in VolMIP, and I think it could be a nice collaborative activity between VolMIP and PMIP. As it is the case for Pastuque, we are collaborating with Pastuque already. So having an eruption during interglacials would be very interesting to think about. I don't know what you think, Christian.
Louise has...
And Louise? Oh, Louise, sorry, because I was looking at...
I can't find my raise my hand thing, otherwise. Sorry. Do the old-fashioned way. I'm sure you're probably absolutely aware of this. I think Kira Reifeld tried this for the LGM with some models a little while ago. So she tried imposing different volcanic forcings for last glacial maximum simulations. I can't remember if she did one to be on that or not. It might be worth pinging her an email and asking her if she's so interested in that. I actually also had, I think that'd be a really nice idea to also have some more interactions between the work groups. So yeah, I wouldn't have any notion particularly of whether it would be more relevant for any of the interglacials, but I think to have some discussion on that sounds a really good idea to me. Okay. I did also have one other point, but I don't know if anyone else wants to talk about, which is on a different thing. So I don't know if anyone else wanted to answer to comment on Massa's and Myriam's thoughts on volcanic forcing first. But otherwise, if I might, Charlie, can I raise something slightly different?
Yeah, no, I don't think anybody else has any questions. So yeah, go ahead.
Okay. This is from Swing 3 is a civil water into comparison thing. I don't know. They got some funding in the US, so there's been a few meetings. There was a Swing 1 and a Swing 2 sort of isotope intercomparison work. So I just thought there was one thing that was being discussed that was very relevant for PMIP at the last meeting, which was slightly standardizing the protocol for if you were also going to run with water isotopes. So I think the feeling in the meeting was that they didn't necessarily want to go about writing their own protocol papers on this, But if there might be space within the protocol papers for the 2K group protocol papers and or the interglacial protocol papers, and maybe if there's other ones being discussed with PMIP as well, it would be quite helpful for isotope modelers just to have written down what the isotope values for meltwater and if there's sea level changes, just a couple of standard values. It wouldn't necessarily need to be a lot, but if that could be possibly added to the list. And I don't know if anyone else has any other comments on that.
I can respond. I think I agree. We have a bullet point on that on one of our slides. So it's there, but we didn't push yet that direction because we are waiting to go to the Pages Open Science meeting where we will have everybody. So to gather the feedbacks. But yes, I think it would be nice to add these aspects in the protocol paper. I agree with you.
That's great. It would be great if we could go in all of them that it's at least relevant for. It might not be all, but yeah, thank you.
Okay, any other questions or comments before we wrap up for today? Just to say that Jean-Yves has put in the chat the link to the PMIP Interglacials website, so check that out when you can. I think that is everything. As a reminder, our next PMIP week's meeting, number 18, is in about 2 weeks on the 20th of March at 2 p.m. GMT, 3 p.m. CET. Where we will hear from Fabrice and Pascal. So with that, I will thank Christian, Louise, Miriam, and Qiong again, and thanks all of you for coming along. Thank you.
Thank you. Thank you. Bye.
Thanks, Darlene. Bye.